Hey guys, this is Beatrice Mititelu, and this is the problem from Calc BC 2004, number 6. Question 6 says, let f be the function given by f of x equals sine of 5x plus pi over 4, and let p of x be the third degree Taylor polynomial for f about x equals 0. So in this problem, you're going to need to know how to construct a Taylor polynomial and how to use the Lagrange error value. Part A asks us to find p of x. We are going to begin by taking the derivative of the function 3 times. So the first derivative would be 5 times the cosine of 5x plus pi over 4. The second derivative would be negative 5 times the sine of 5x plus pi over 4. And the last derivative would be 5 times negative 25 times the cosine of 5x plus pi over 4. So now we're going to begin to plug in 0 in each of the f functions. So f of 0 is the square root of 2 over 2, f prime of 0 is 5 times the square root of 2 over 2, f double prime of 0 is going to be negative 25 times the square root of 2 over 2, and for the last one it's going to be negative 125 times the square root of 2 over 2. So because the problem says that p of x is a third degree Taylor polynomial, we need to know how to construct a polynomial. So because this is centered at f equals 0, we use the Maclaurin series. So you can pause it here if you want to look at the formula for how to build a Maclaurin series, but we're going to move on. So we have our p of x function, and the first term is going to be f of 0, which is the square root of 2 over 2. Then we're going to add 5 times the square root of 2 over 2 times x over the 1 factorial as well. Then we're going to subtract 25 over the 2 factorial times the square root of 2 over 2 times x squared. And then we're going to subtract 125 over the 3 factorial times the square root of 2 over 2 times x cubed. So you can see here that 4 points were awarded for constructing p of x, and points were deducted each time a term was missing, or for an extra term, or a misuse of the subtraction sign. So part B of this problem asks us to find the coefficient of x to the 22nd in the Taylor series for f about x equals 0. So going back to the Maclaurin series formula, we can see that f to the n of 0 times x to the n over n factorial gives us the nth term. So if you want the 22nd term, then we can plug in 22 for n. So here we're just plugging in 22 for n, and we see that the coefficient of x to the n is 5 to the n times the square root of 2 over 2 over n factorial. And we see that because at f of 0, it's 5 to the 0, at f prime of 0, it's 5 to the 1, at f double prime of 0, it's 5 to 2, and so on. And each time the constant is the square root of 2 over 2, and the factorial increases by 1 according to the term as well. So that's where we get the 5 to the n, the square root of 2 over 2, and the n factorial from. But now we have to ask ourselves what sign it will have, a positive or a negative. So to find out if it's positive or negative, we take the derivative of sine until we get back to the original function. So the first derivative is cosine of x, the second derivative is negative sine of x, and the third derivative is negative cosine of x. And we take the derivative one more time and we get back to the original function, which is sine of x. So now we're going to count out the 22nd derivative to see if it's positive or negative. 22. So we find that the 22nd derivative is negative. So now we can begin to construct the 22nd term. So it will have a negative sign, like how we found from earlier, the 5 to the 22nd, the square root of 2 over 2, and the 22 factorial. So we see that 1 point was awarded for the sign and 1 point for the magnitude of the term. So part C asks us to use the Lagrange error bound to show that f of 1/10 minus p of 1/10 is less than 1 over 100. So in the Lagrange error bound, we use the next term from the series. So in the p of x series, it was the third degree. So to find the error, we would use the fourth degree term. So here we're just going to write out the fourth degree term, which is going to be f, the fourth derivative of f of some number, times x to the fourth over the 4 factorial. In order to find the fourth derivative of f, we rewrite the third derivative, which is negative 125 times the cosine of 5x plus pi over 4, and we take the derivative of that, which is 625 times the sine of 5x plus pi over 4. We want to maximize our fourth derivative of f, no matter what our c is, and we know that the max value of sine is 1, because when you look at the graph of sine, no matter what input you put in, you see that the output, or the max output, will always be 1. This allows us to replace sine of 5x plus pi over 4 with just 1. So our fourth derivative of f with c is just 625 times 1. So we can construct the fourth term, which is 625 times x to the fourth over 4 factorial. And we already know from earlier in the problem that x is 1 over 10. So we can substitute that in for x. So 625 over the 4 factorial times 1/10 to the fourth is less than 100. Or that should say 1 over 100. So when you simplify the term, you get 1 over 384 is less than 1 over 100. So you see that 1 point was awarded for the correct inequality. So in part D it says, let g be the function given by g of x is equal to the integral from 0 to x of f of t dt. Write the third degree Taylor polynomial for g about x equals 0. To begin, we simply write out g of x, which is the integral from 0 to x of f of t dt. And we're looking for the third degree Taylor polynomial. Because we already know p of x, which is the third degree Taylor polynomial of f, we can just substitute those first 3 terms into the integral. Then all we simply have to do is take the integral of the terms, and you get the square root of 2 over 2 times x plus 5 times the square root of 2x squared minus 25 over 12 times the square root of 2 times x cubed, and that's the answer. So on the scoring guidelines, we see that 2 points were awarded for the Taylor polynomial for g about x equals 0, and 1 point was deducted for each missing or incorrect term, and 1 point was deducted for extra terms or the misuse of the equality.